In this video, you will learn about the transformation of quadratic functions. So the quadratic parent function is given by the f of x equals to x raised to the power of 2. And I show you the graph here. So when we talk about the changes to the quadratic function, you want to focus on how does the vertex, which is normally represented by hk, how that vertex is moves. So you can use the Desmos calculator to graph the functions. So the transformation of quadratic function can be represented in this general form. This is if you are familiar with this is the vertex form of the quadratic. Again, the vertex is the h, comma k. H is the x value of the vertex, yk is the y value of the vertex. So let's talk about the parameters a, b, h, and k. For the parameter a, so when a is negative, that means if you have something like -2, -3, when a is negative, so first that sign is also like causes a change to the graph. So that sign negative will make the graph to be reflected across the x-axis. So now when the absolute value of a is greater than 1, so this will cause a vertical stretch. Vertical stretch means stretching along the vertical direction, okay? Just imagine yourself playing with a rubber band. So when a is between 0 and 1, that is the absolute value of a is between 0 and 1, so you are thinking about 0.1, 0.2, 0.3, 1/3, 5/6, stuff like that, fractions or decimals. So you are going to have a vertical compression or a sink. So think about pressing down a ball, a soft ball, along the vertical direction. So you know that the ball will spread out on the side. So now talking about the k, which again is the y value of the vertex. So when you add k to this function like it is, when k is positive, the graph will move up, and when k is negative, the graph is going to move down. So we call k a vertical translation. So vertical translation means translation is just a shift in the position or location. So k causes a shift up and down, okay? So let's talk about the h. The h again is the x value of the vertex. So to talk about h, I want you to consider consider the entire equation, okay, inside this parenthesis. So when the equation is negative, that will cause the graph to move to the right. So we call that an horizontal translation to the right. Then when the equation is positive, so it will move to the left. So what I want you to remember here is the sign of the equation, that is s minus h. So the movement is opposite the sign. So if it is negative, it will move to the right. If it's positive, it's going to move to the left. So now to the b. So what you also need to remember is that this b is inside the parenthesis. So the b, when it's negative, is going to be a reflection across the y. So look at yourself. I mean, like if you are taking a selfie and you are looking at your reflection in the mirror, you know. So that's a reflection across the y, okay? So when the absolute value of b is greater than 1, so we are going to have horizontal compression. So again, when you compare a and b, so you can see that when the absolute value of b is greater than 1, it's going to be a horizontal compression, not a shrink like in a. So when the absolute value of b is between 0 and 1, so you are going to have an horizontal stretch. So what do I need you to take home on this slide? I want you to remember that a and k, they are outside they are outside, so, and they are vertical, okay? Again, a is changes across the vertical direction, so you have you have a shift, like like when you are standing on a well, like when A is negative, so it's like as if you are standing beside a pool of water on a rainy day, and you can see the reflection of yourself, okay, in the pool of water. So that's like a reflection across the X. So, and K is a translation up and down, okay, so it's vertical. Whereas the B and the H, they are both inside, so they are horizontal, okay, horizontal. So the distinction between A and B is that one is vertical, which is A, B is horizontal, and K outside, or vertical, H inside, horizontal. Okay, now let's talk about the parameter A. So in this case, I'm going to give you two examples to quickly review what the changes in A. Again, you can use Desmos to actually graph and see those changes. So for this example one, so we want to describe the changes in this function G relative to the parent function f of x. So now this is the parent function f of x, okay? And now you see, if I just graph the negative s squared, so I see so this is the reflection across the x. And now if you now graph the entire g of x, so you now see that in addition to being reflected, you can see that this graph is also appear to be narrower than our parent function. That means it has been stretched along the vertical direction, okay? So what do we have? We have a reflection across the x-axis, and we have a vertical stretch by a factor of 2. So example 2. So again, we are supposed to be describing the changes or the transformation that we see in this graph g of x, which is the 1/3 of x squared. So it's only one change because in this case, our A is 1/3. So this is the parent function again. And now you can see that there is a vertical compression, okay? Vertical compression. So that is why the graph appears to be wider than our parent function. So vertical compression by half. So K is also like again, vertical shift up and down. So I put this arrow just to let you be able to remember that K is also like vertical translation up and down. So example 1 of that for K. So you can see that K is just being added to this parent function. So this is being added to it. So that is just going to move the graph up by 3. So the graph is going to shift up by 3, or you can say translated up by 3. Okay, so this is g of x. So again, we are subtracting 3 from the parent function. So this is the parent function again, and so that will cause the graph of the parent function to just move. So you can see a shift in the vertex from 0, 0 to 0, -3, okay? So there's going to be a shift down or a translation down by 3. So B, so again, parameters B is our horizontal parameter, so that affects the function. So now the difference between A and B is you can see that B is now inside the parenthesis, and it is the coefficient of x inside the parenthesis. So now this is the parent function again. So our B, so instead of being, so this is a compression. So this is going to be a compression. So imagine like you have a ball and you are pushing it along the side. So that's a compression by 1/2. So example 2, so this is the case that B, so example 1 is a case that B is absolute value of B is greater than 1. And example 2 is the example that B is between 0 and 1. So in this case, it's 1/3. So this is the parent function. And then you can now see is the horizontal stretch. So that's why the graph appears to be wider, because it's as if somebody is pulling the graph along the so it's like somebody is pulling this graph out along horizontally, okay? So now you have horizontal stretch by 3, a factor of 3. So again, H moves the graph along the horizontal direction, okay, to the left or to the right. So I'm not going to waste time on this. So there you go. So again, you have the h being inside the parentheses. So, and again, this is s minus 3. S minus 3, so we'll move it to the right by 3, okay? And example 2, we'll move it to the left by 3 because this is positive. S plus 3 is positive. It's going to go left. S minus 3 is S minus 3. S minus 3 is negative, so it's going to move to the it's going to move. So S minus 3 negative is going to move to the right. Okay. So in a nutshell again, so this is now a general form of transformation. So what I've just described, the parameter a, b, h, and k, they affect every function the same way. So you can put absolute value function, you can put rational function, cubic, cube roots, logarithmic, exponential function, any type of function, linear function. So all these parameters a, b, h, and k, they affect that function the same way. So that is why transformation, when you learn it for one function, it's like you learn it for every other function. So I want you to bear that in mind. So this is a general form. So instead of showing a quadratic function, I'm just showing an f of x, where the f of x is now the parent function. So f of x is our parent function in this case. And f of x, so will be the parent function in this case. Okay, we represent the parent function in this case. So, and the g of s is now the transformation equation. So again, this works for every types of function. So you can see a and k, they are vertical, okay? K is up and down, a is along the vertical direction, and then b and h is sideways, horizontal. H, we move it left or right, okay? So let's look at example number 1. So example number 1, the question is, which graph can be obtained by translating h of x down? So let's first highlight the keywords. So we have translate, we have down, 7 units, okay? So they want to translate h of x. And if you look at h of x also have a, so we have 0.33. So this is a, and we have positive 2, which is our k, okay? So this a is less than 1, so that means a vertical compression. And this has been moved up by 2, so let's come here and just sketch what h of x looks like before the new transformation. So, okay, that's not good. Okay, anyway, so this is our h of x before. So now we want to move this down by 7 points. So that will make it to end up at -5, okay? So we will have the new graph being like that. So definitely option A, option B is not, option D is not. So our answer is C, okay? In this case, the correct answer is C, okay? Example 2. They said the graph of y is shown below. So look at y. Y is moved down by 2. That's k, okay, k. And a is 3. So there's a vertical stretch. That's why the graph looks very narrow. So they are now saying if the coefficient of s squared, so let's highlight the keywords. If the coefficient of s squared is changed from 3 to another positive number to create a new function. So what does that mean? So we are changing a to another positive number, could be 2, okay, could be 1.5, could be 10, could be 8, could be 7, okay? So that means we are changing k from one vertical stretch to another, okay, to another stretch. So the higher the vertical stretch, the narrower the graph we get, okay? And let's say if we are moving from 3 to 2, that might become wider too. But what you have to know is that the graph is not going to shift in vertex because this is not k or h. So let's look at the options. The x-intercept of the new graph will be the same. We know that that is not true. The x-intercept is not going to be the same. That's not true. The vertex of the new graph will be different. That's not true also. The vertex does not move when you are just changing k. The new graph will be wider or narrower. So that is looking like our answer. But let's look at option number D. The new graph will open in the opposite direction. So they are trying to say there's going to be a reflection. But since we did not change the graph to a negative number, there is no way we can have that. So again, for this question, the correct answer is C. So this is another example. So in this, you are supposed to find a statement that is false. So you are looking for the false statement, okay, about the three functions f, g, and h. So let's look at the statement. The graph of two of these functions have a minimum point. So look at f and g. F and g, we know they are going to look down, isn't it? So they are going to have a maximum. So two of these functions, so that's a false. And that might be our answer. So, but before you can decide, let's read the other choices. The graph of all these functions have the same axis of symmetry. So axis of symmetry is s equals to h. I have told you that the h is the x value of the vertex. So, and you can see from this graph, there's no h is 0. So definitely x is equal to 0 is the axis of symmetry. So that's true. So all of them have the same axis of symmetry. The graph of two of this function do not cross the x-axis. So for a graph not to cross x-axis, that graph of quadratic must have been moved up. Okay, if it is looking, so if it is this way, it must have been moved up. So yes, this is positive, it has been moved up. So that is true. Or if it's looking down, and then it is also shifted down. So look at G. G is looking down by A being negative, and it's also shifted down. So yes, so G is also not going to cross the x-axis. So that's true. Whereas F is going to cross the x-axis because even though it's looking down, it is shifted up. So the graph of all these functions have different y-intercepts. Of course, they are going to have different y-intercepts. Why? Is because of the shifting up and down. So that's the y-intercept is actually going to coincide with the where they are being moved up and down. So that's also true. So yes, so the answer is A. Thank you. So that's the end. Thank you so much. Bye.